Hey everyone, it's Mr. Logeman here. Again, if you haven't seen me before, I'm a student teacher helping out here for about 7 weeks with Mr. Geiselhart, and so you'll probably see more of me. But today we're going to talk about surface area and volume of cylinders. So there's two very helpful things you have going for you as we go into these problems. One, I think you all have an idea of what a cylinder is. You've heard of them, you've talked about them, you've seen them, and when I say it, I think many things come to your head because you have a good understanding of what it is. If you don't worry, we're going to review them, but I think most of you do. The second helpful thing is that you already solved the surface area and the volume of prisms last week. And while there are a few differences, I promise there's a lot more similarities between these problems than there are differences. So I think you're going to find the problems this week going a little bit faster than last week. So on the screen, I've just put up a few classic cylinder examples. Top left here, we have Pringles, a big fan of mine. I really like them. And then over here, we have a pop can. And while, yes, there's a little slanted surface here, in essence, it has a cylindrical shape. There's a circle on top, circle on bottom, and a connected curved surface. Down here, we have a piece of firewood here, a very straightforward log that is a cylinder on its side. Down here, we have the famous Leaning Tower of Pisa. I don't know if you know about it or if you've been there. I haven't been there. Frankly, I'm kind of forgetting where it's from, but it's a very famous structure that is it's like a cylinder. You can see down here where it is very close to that cylinder shape, but it's actually leaning. It's tilted a bit to its side. And that's going to be a certain kind of cylinder we're going to get to in the third problem. And so we'll talk about that in a second. But most importantly, in this weird time that is COVID-19 when we're stuck at home, we have toilet paper. Yes, a very classic cylinder you see every day in your homes, and I hope and pray for your sake that the radius of that cylinder is a little bigger than the cardboard circle in the middle. Lastly, I have more of a mathematical diagram down here to just give you a sense of the actual structure of a cylinder, where a cylinder has two circles, one on top and one on bottom, and all the edges of that circle. I mean, it's one edge of that circle, but that entire edge is connected on the top and the bottom to form a curved surface. And there's only two measurements that define a cylinder, the radius and the height. So in theory, if I told you the radius and the height of a cylinder, you could recreate it because those two measurements alone define the shape entirely. So let's go forward here. I want to give a brief explanation of what a right cylinder is because that's where we're going to start today. Now, a right cylinder is what you probably think of as a normal cylinder. If I asked you to go in your home and find a cylinder, which if you need a break from your computer, I think it's a great idea to go look for a cylinder in your house, but you're probably going to find a right cylinder. And all that is where the circle on top and the circle on bottom, in essence, are directly above and below each other. Meaning if you took a line from the center of the top circle to the center of the bottom circle, it's going to form right angles with both of those circles or bases, which we'll get to in a second. We're going to see some where that's not the case, and those are called oblique cylinders, and we're going to get to how those work in a little bit. But I want you to have a brief reminder of how that works before we go forward. So we're going to have you go to an assignment in Canvas, and that's called Unit 9 Surface Area Number 2. And this video I'm making is directly based on those problems. So I promise if you go through that assignment right alongside this video, you're going to do a great job, and that's going to get you some easy points on those problems. So I really suggest you do that. The first problem is a right cylinder, where I've asked you to find the surface area and the volume. Be very cautious about the numbers I give you. This right here would be what we call the height between the two bases, but this right here is not the radius. Clearly this line extends from one edge or from one side of the circle to the other side through the center, so that's diameter. So it's gonna be very important that you watch out for that as we're going. But to think of the structure again of the cylinder, we have two bases, which are the circles, and the lateral surface is that curved surface connecting the two. Just like we talked about last week with the prisms, how there's bases and lateral surfaces, the same goes here. So I'm going to give a brief explanation of what that lateral surface actually is. So if you were to find maybe a pop can or some other cylinder in your home, and you're going to try to figure out what that lateral surface is and how to find the area of that shape, it may be a little confusing, but I'm going to tell you, it's a lot simpler than it may seem. So I have a little GIF here to show how that works. So we're a little through the video here, so I'm gonna wait till it gets to the beginning, but this little GIF is gonna give you a sense of how we find the surface area. So here we have a normal cylinder, and you'll see what they're gonna do here. They're gonna peel those sides open, and when they do so, they get the bases, the circles from the top and the bottom, and then a rectangle, which is kind of interesting, but when you think about it, it makes sense. That rectangle, one of the sides is the height, and the other side is actually the circumference. Watch it again, and hopefully you see how it works. Unrolling out to a rectangle, and if we roll it back, that top side of the rectangle matches the circumference exactly. So it's actually pretty doable to find the surface area because we only need to find the area of 3 shapes, 2 circles and a rectangle. And I know you know how to find the area of those shapes. All right, so let's get right back into this. I'm gonna make my video a little smaller here so all the words fit. But to start out, we wanna have you find the area of the 2 bases together. Again, the bases are a circle, and I think you know the area or the formula for the area of a circle. And if not, I have it here for you to look back on. But the formula for the area of a circle is just pi r squared, pi times r squared. But we have 2 of them, so in a second, we're gonna need to double it. But let's just find the area of one of these circles. So we're gonna have pi times, again, 3.5 squared because this is the diameter, not the radius. We need half of that. So pi times 3.5 squared, which ends up being 38.48. But again, we want the area of both bases. So if I just put this number right here, I'd be wrong. I have to double it because we have 2 circles. So I went ahead and did that. This is exactly double this 38.48. Now the lateral surface area, again, it's a rectangle where one side is the height of the cylinder from base to base, which is 20, and the other side is the circumference of the base. So I'm going to call lateral surface area, I'm just going to say LSA for lateral surface area. And reminder for circumference, we generally think of it as 2 pi r, but 2 times r is just the diameter, so we can really do pi times d to be a little simpler in this case. If you're given the radius, you can think in 2 pi r. Either way is fine as long as you know that you're finding the circumference. So here, pi times d is the circumference since I give 7 as the diameter. And then here's the height of the prism. So we're gonna get pi times 7 times 20, which gets us 439.82. And here we don't need a double because there's only 3 shapes making up this 3-dimensional figure. We have circle, circle, and lateral sides. So I can go right in the box here. And for total surface area, all we need to do now is add together the area of the bases and the lateral surface area. So 76.97 plus 439.82 is 516.79. So for your reference, if you're looking back at this video for help, this is kind of a basic formula for the total surface area of a cylinder, where this is the area of the 2 bases, and this is the area of the lateral sides right there. Finally, to find the volume of this shape, really very similar to the prisms here, where you want to find the area of the base times the height. Because if you think of finding the area of that base times by the height is going right through the entire center or the inside of that shape. And volume wants to find the inside of the shape. So it's the area of the base times height, which again, the area of the base is just pi r squared times height. So we get pi times 3.5 squared times 20 for a grand total of 769.69. And let's check here to ensure I was correct. See if I put it in the problem or in the assignment on Canvas. Those were all correct. They got the green check. All right, let's go forward here. The next problem is finding the surface area and the volume of a half cylinder. So for a half cylinder, it's exactly the same as a cylinder, but we've cut it straight down the middle through the diameters of each circle. So it's exactly half. And so I want you to, if you have a chance, pause for a second and just think about how that may affect the surface area and the volume. But we're going to do the surface area first. So again, we want the area of the 2 bases together. Now, remember the area of a circle is pi r squared, and before we had to double that because we had 2 circles. But here we have 2 half circles, which just makes 1 full circle. So we can really leave this formula as it is, which is pi r squared. So we get pi times 12 squared for a total of 452.39. Again, that covers both bases, so we're set for that part. Now let's go to the lateral surface area, and that's actually split into 2 parts. We have this curved part right here. We also have the bottom of the shape, that rectangle on the bottom where we slice through. So CSA, I'm saying the curved surface area, if that's okay. So again, to find the curved surface area, we had taken the circumference of the circle, of the base, times the height. And so here, we can do the same thing, the circumference 2 pi r times the height, and then just divide it by 2. But you'll notice we have times 2 over here and divided by 2. So those can cancel out. And for this problem, that curved surface can just be pi RH, which is pi times 12 times 12. When you do these problems, you're likely not going to get 12 and 12, or you're going to have the same number. But here, 12 is the radius and 12 is the height. And that gets a total of 452.39. But that is not the total lateral surface area. We still have that bottom rectangle. Now, I've said bottom here. It may not always be the bottom. You could have this sitting up where it's one of the sides. But in this case, I've written bottom because it's clear that that's the rectangle. So here, one of the sides is the height, and one of the sides is the diameter. Pretty straightforward. We're going to get 24 times 12, which is 288. And then adding those together for the lateral surface area, we get 740.39. And finally, for the total surface area, we just add these two numbers, and that gets 1,192.78. So again, a reminder for the half cylinder, this total surface area, the basis is just pi r squared, the curved surface is pi r h, and the bottom is diameter times h. And again, for explanations of why, go back and watch the last part again if you need to do so. Going on to volume here, same thing. We're going to do the area of the base times the height. But in this case, we can kind of just think of it as the volume of the cylinder with these dimensions divided by 2. And you'll see that in a second. So our volume is pi r squared h, which is the volume of the full right cylinder, times 0.5, which is just pi times 12 squared times 12 times 0.5, which equals 2,714.34. And again, you'll see if you do that in your problems correctly, you'll get the green check mark. All right, finally, we're going to talk about the oblique cylinder. So I mentioned in the beginning the right cylinder, where the circle on top and bottom are directly above and below each other, and they form a right angle. An oblique cylinder is where that circle on the top is offset a little bit. So if you were to draw a line from the center of the top circle to the bottom circle, it would not form a right angle. So really, the right cylinder is a special case of the oblique cylinder. But we want to study the volume of this shape. So let's talk about that. How would the volume change from a regular cylinder to an oblique cylinder? And I have that represented here in stacks of poker chips. So let's think about this. If you have a stack of poker chips in a right cylinder, if you consider the volume, and then you were to spread those offset a little bit, or kind of spread them to the side, so all the poker chips are offset, you would now have this leaning tower. But it has the same height as the original cylinder, and the structure of the base is the same. It has the same radius. And each of these poker chips have the same density or the same material in them. So you'll notice we actually didn't change the material at all, the amount of material inside or the volume inside, by offsetting them. Now, yes, there are these little steps. If you were to look at this very closely, you'd see little steps. But what if we took thinner and thinner discs? We could do the same thing until that little step is almost gone or not important, or we don't need to think about it because it's such a small difference. And so actually the volume is not going to change if we have a right cylinder or an oblique cylinder. And you'll see that here. So here I have an oblique cylinder with a radius of 7 and a height of 24. So same as before, volume, the area of base times height, or pi r squared times height, which is pi times 7 squared times 24, which equals 3,694.51. And again, if you've watched the video all the way to the end, thank you very much for tuning in. And I've given you a gimme point, a freebie point, because here this question, the volume of a right cylinder with the same radius and height is the exact same answer. Now, one word of warning. When we say height for oblique cylinders, we mean the vertical height from one base to the other. See how this line right here does not go from the center of this circle to the center of the top circle. That would be a slanted line. Here, this is the line going straight up and down. If you have a slanted line, you're going to have to do a little extra math to get this number here. But in this case, I've given you the vertical height, and that'll do everything you need. And again, those are correct. Yay for me. Very exciting. So I'm going to stop the share here. That's really all there is to the cylinder problems, the surface area and volume. Not too difficult, pretty similar to the ones before. And I think they should go pretty well for you. If you have any questions, please reach out to me or Mr. Geiselhart, and we'll help you along. But I hope you do a great job this week. Thanks for tuning in.